Hello, this is the final presentation of our group G06, Paddy Dehumidifier. This is our member. Here is our problem of statement. As we told you before, due to the problem in finding drying area to dry the rice, some farmers decided to dry the rice on the public way, which can cause an accident. So we want to make this machine in order to solve this problem. We have defined the objectives to make it clear about what the benefits of our machine. And we also define scope, which is the knowledge we need to know to make this machine. In data analysis, from our research, we knew that off-season rice can produce the product more than the wet-season rice. But both of them have faced the same problem. It's humidity. After harvesting, the average humidity is around 25 to 30%. Thing is, rice mill will accept the rice that have 15% of humidity all over. If it's over, farmers will be charged for 225 kg per ton for drying in exchange. In order to know the farmer requirement, we have done the interview with farmer, and this information on the left-hand side is what we get. Then we adapted into engineering characteristic for measure and to show our machine performance. To make it clear about what this machine can mainly solve, we have defined the problem as our target to solve, and the solution of this problem is on the right, which is the main benefits from our machine. Next is house of quality. We made house of quality in order to sort the rank of engineering characteristics, and we got the three most important engineering characteristics. First is dehumidifier performance, second is price of the machine, and the last one is producing late.
From three important points from house of quality, we will select the most appropriate components from this decision matrix. As a result, on the right, receive rice with flat tray and feed screw, circulate rice by free fall and bucket aerator, using LPG as heater fuel, and transfer rice out of machine by change direction of circulation. After we design the components, we use function decomposition to plan how our machine works. As you can see in block diagram, we separate our machine into 5 modules to assign parallel works for our staff. In work breakdown structure, we separate our project into 4 main parts: customer segment, conceptual design, detail design, and production. And we use last slide information to make this Gantt chart. We predicted this project will take 18 months. From Gantt charts, we can accelerate our project by reschedule some process into parallel tasks. So this critical part shows how we do that. The result is our project will take 495 days, that is 16.5 months, which takes 1.5 months faster.
In parametric design section, we will analyze the size of component. First, we need to define the capacity of our machine. Then we will based on the maximum capacity of pickup truck, that is around 2,000 kg. After that, we need to determine paddy circulation. So we choose screw conveyor and bucket elevator for this process by setting condition at 5 times of machine capacity in 1 hour. Then we need to select spec of them as following to calculate the load that apply to shaft. Finally, we will know the load that apply on the bucket elevator shaft is about 109 kg, and the proper diameter of shaft is 50 mm.
In this slide, we will focus on hot air supply system. We can divide it into 2 processes. The first process is air heating. It is working to generate hot air supply by heating up ambient air from the outside with LPG combustion. and then send them to the another process. The second process is air humidifying process. It receives hot air from the heating process to heat up paddy and pull out some of the moisture to the exhaust air. This process is working to make the paddy dry enough to sell in the market. This slide explains the parameters and result of the calculation. It comes out that the net power consumption of this system is equal to 970 megajoule. That means when we use this machine to dry up 2,000 kilograms of paddy for 5 hours, it will cost you 1.3 tanks of 15 kilogram LPG, which equal to 477 baht.
So this slide show you the exploded view of bucket elevator.
In the shop floor drawing section, we consider the bucket elevator pulley part because it involved with the power transmission system that affect to the production rate, efficiency, and other customer requirements. The pulley part has cylindrical shape with a tube and 2 plates. They are assembled with clearance fit and tied with screws. In the contact surface, we select 3.2 surface roughness and select 6.4 for the other. The GD&T is defined as cylindricity of 0.06 mm and position of 0.05 mm. The tolerance and fit is selected as clearance fit with H7 F7 type, which make positive max and min gap. In material selection, we use table to evaluate properties of each material we have expected. Each property may affect to customer requirements. From the table, we can choose alloy steel AISI 4340 as our overall material, since it has the lowest sum value. That means it has proper properties that match with our customer requirements.
In part of manufacturing cost, we calculate material and processing cost from CAD that we design. Labor and overhead cost can decide from critical part, and then production cost is 263,032 baht per unit. So we set price at 550,000 baht. So our margin is equal to 52%. In marketing plan section, our customer segment is 5% of farmer group or selling 40 units per year. So our machine can help add value to crop about 550 baht per ton after deduct fuel cost. And our machine can pay back in 2 years in case of group has 28 people or more.
The conclusion of our project can be explained as this business model canvas. Our customers are farmers who have been exploited by the rice mill companies. This machine will take a role in increasing income for the farmer in long-term application. Thank you for your attention.